Today we're going to talk about polynomial long division. So for the first part, we're going to use the properties of exponents to divide a monomial by a monomial and a polynomial by a monomial term. So remember that monomial just means one term, polynomial means many. And remember, terms are separated by addition and subtraction. So looking at this first one, if we divide 48 by 6, we know that's equal to 8. And when you have something with the same base being divided, remember you subtract the exponent. So this would be 2 minus a to the 2 minus 5 and b to the 7 minus 3. And then we can simplify. So this is a times 8 times a to the negative third power and b to the fourth power. And remember, we don't like negative exponents, so this becomes ab to the fourth over a to the third, so that negative exponent for the a means that the a goes in the denominator and becomes positive. When we have more than one term in the numerator being divided by the one term, we can separate it to help us divide. So 24x to the fourth y minus 12x squared y squared, and then just separate the terms. So 12x squared y divided by 12x squared y. And so then the next step would be just to simplify each of the different terms. So 24 divided by 12 is 2, and then x to the 4 minus 2, y to the 1 minus 1, because remember it's 1 for the exponent when it's not written. And that's all being subtracted by 12 over 12 is just 1, x to the second minus 2, and y to the 2 minus 1, and then simplify. So this gives us 2x squared. Remember that y to the 0 power, anything to 0 power is 1, so we don't really need to multiply that by 1. We can just leave it like that. And then again, we don't need this 1 placeholder, so x to the 0 power again is 1, and then this would be y to the first power. Go ahead and do number 3 on your own, and then when you're done, unpause the video. So 6r squared s squared over 3rs plus 3rs squared over 3rs minus 9r squared s over 3rs. And then when you simplify each term, you get 2rs plus s minus 3r using your properties. So then for the next part, polynomial long division. So recall that the dividend equals the divisor times the quotient plus remainder. If the division has a remainder of 0, then the divisor and quotient are said to be factors of the dividend. If the division does not have a remainder of 0, then the divisor and quotients are not factors of the dividend, and the dividend must be in standard form. And if needed, add in 0 placeholder. So we'll talk about what all this means just as reminders. So looking at the first part, if you have 600 divided by 12, remember you could also write that as 600 divided by 12. And back in grade school, we learned how to use long division to divide this. So when we did our long division, this was on the outside, and underneath was the 600. And so remember that this is called the dividend. And then this is called the divisor. And the answer will be the quotient. So when we first did this, remember we said how many times does the 12 go into this 6? Well, 12 is bigger than 6, so we would then go to the next number, that numerical value that we have, so 60. So how many times does 12 go into 60? It goes 5 times, and then remember you take this 5 and you multiply it. So 5 times 12 gives me 60, and then we subtracted the terms when we did our long division. So these, of course, cancel out, and then you bring down the 0. So how many times does 12 go into 0? Of course, that's 0. So 0 times 12 is 0, and so that means the remainder is 0. So that means that 12 times 50 equals, of course, 600. So 12 and 50 are both factors of 600. Of course, then the answer to this entire equation is just 50. and that's again called the quotient. So let's go ahead and do another one. So this is the same thing, is 5,627, and then you can write over the 4 that like this, and so we're going to use our long division. So 4 goes on the outside, and then we have 5, 6, 2, 7. So how many times does 4 go into 5? It goes once, and then you multiply. 4 times 1 is 4. And then remember you subtract. So that gives us 1, and then you bring down the other term, so 6, 2, 7. And so then now you're saying how many times does the 4 go into, because we already did the 1, and 4 doesn't go into 1 anymore, so 4 into 16. So we know that's 4 times, and 4 times 4 is 16, and then you subtract, and then this cancels out. So then we get 27. How many times does 4 go into 2? It doesn't. So how many times does 4 go into 27? It goes 6 times. And then you multiply 6 times 4. It's going to give us 24. And then you subtract, and that gives us 3. And then, of course, there's no other spots to go, so then the rest of it ends up being decimals, or again, you can write it as a fraction, so this is the remainder. So for this, you could, of course, then write this as 1,406, and what's left over, 3/4, and 3/4 because of that 3. And so for this, that means that 4 is not a factor of 5,627 because the remainder is 3. And so remember we said the dividend is equal to the divisor times the quotient plus the remainder. So just to show you, if you were to plug that into your calculator, we have 1,406 times 4 plus 3, and that gives us our dividend. All right, so why are we learning how to do this? Well, we're learning this because remember, we like to know how to divide polynomial factors in order to find factors of your equation, because then that helps us graph it without using a graphing calculator. So this is going to be just another way of finding the factors of a polynomial. So the first thing, in order to do that, we have to know how to actually do the division with a polynomial. So that's why we were looking at long division numerically first. So remember, this can be rewritten as x squared plus 7x plus 10 divided by x plus 2. Now this is different than what we did up here, because notice that each of these terms up here were just divided by one term. So when it's divided by one term, you can do what we did up here and use the properties of exponents. When we are dividing by multiple terms, in this case a binomial, we have to do something different, which is our polynomial long division. So the first thing you want to do, just like we did up here, you want to set up your equation. So x plus 2 goes here, and then x squared plus 7x plus 10. So remember earlier I said to make sure that the dividend must be in standard form, and if needed, add in 0 placeholders. So if we look at our dividend, it's in standard form, and I'm not missing any 0 placeholders. Like if this 7x wasn't here, I'd have to put 0x in, because every thing you do in this needs a place to go. So for this, the first thing you want to do is look at, just like up here, how many times we said, how many times did 12 go into 6? And then we said it didn't, so how many times did 12 go into 60? And over here we said, how many times does 4 go into the 5? So same thing, how many times, and there's two terms here, but you start with the first term. So how many times does x go into x squared? So the way that I remember this is I use DMSBR. And we'll talk about what that means in just a second. So some people have made this up over the years. So does McDonald's sell burgers? Repeat. or whatever you want to use to remember D, M, S, B, R. So D stands for divide. So you divide those first terms. So I like to do my work off to the side. So my first term's x squared over x, which makes sense because look right here, x squared over x. So if we divide x squared over x, this is why the properties of exponents are important, because you subtract these exponents and you get x. So then now you're going to line this x with its linear term. So these are the linear terms here. So I line it above this one, not this one here. And then M in McDonald's stands for multiply. So I take this x and I multiply it by both these terms. So x times x is x squared, and x times 2 gives me 2x. And then remember, like up here, the next step was to subtract. So here, the S in cell stands for subtract. So you have to subtract each of these terms. So this gets subtracted and this gets subtracted. So x squared minus x squared cancels out, which we did on purpose, kind of like what we did it up here, that 60 canceled out because we're trying to figure out if it's a factor or not. So then x times the 2 gave us a 2x, and so we're going to subtract these terms now. So 7 minus 2x gives me 5x. And then the next one is B, stands for bring down, so we're going to bring down the 10. And then R stands for repeat, so we repeat the steps again. So D stands for divide. So divide what? The first term. So how many times does x go into 5x? So do your work on the side. So 5x divided by x gives us 5. It's positive, so plus 5, and this is a constant, so it goes above the constant terms. So then the next step we do is we take the 5 and we multiply it by both these terms. So 5 times x is 5x. 5 times 2 gives me 10. And then again, S stands for subtract. So this cancels and this cancels, so that means that 0 is left over. There's no other spots for us to go here, so this is the remainder. And so that means, remember that if you get a remainder of 0, then x plus 2 and x plus 5 are both factors. So x plus 2 times x plus 5 should be equal to x squared plus 7x plus 10. And of course, they are both factors of x squared plus 7x plus 10. And you're saying, well, why couldn't I just factor that to kind of go ahead and see that? Well, you could have factored to find that if I factored to find the actual solution, because this is the answer right here to the entire equation, x plus 5. If I factored that numerator to begin with, I would have gotten x plus 5 times x plus 2 over x plus 2, and then you would have noticed these canceled to give me x plus 5. It's just another way of doing division to figure out what the solution is to find a factor, because there's going to be some equations where you cannot factor, so that's why it's important to know. So I'm going to write over here, so again, the D was divide, the M is multiply, the S was subtract, and then B is bring down, and R is repeat. So these are the steps that we're doing for our polynomial long division. So let's go ahead and do another one. Okay, so we have the x minus 5, and that's underneath is the x squared plus 2x minus 30. I noticed that it is in standard form. We're not missing any 0 placeholders. I'm going to do my work off to the side here. So D stands for divide, your first terms. Here's my first terms, x squared over x. So that means that gives us x. You line it up above the terms that it goes with. This is linear, so it goes above the linear terms. And then M stands for multiply. So x times x is x squared. X times negative 5 is minus 5x. S stands for subtract. So this gets subtracted, and then if we subtract a negative, remember that becomes positive. So I like to circle that I've already changed the sign so I don't forget. So this cancels out, and then 2x plus 5x gives me 7x, and then bring down the negative 30. If it helps you instead to put the negative on the outside, some people like to do that. So this was minus, some people like to subtract like this, and then remember to distribute. Whatever helps you is fine. Like I said, I just like to subtract the signs and circle them because it helps me not to forget. So then we're going to go ahead and do repeat. So repeat the steps again. Divide your first term. So 7x divided by x gives me 7. It's positive, so plus 7. M stands for multiply. So this gives me 7x minus 35. S stands for subtract. So we're going to change the sign. So 7x, and this becomes minus 7x, cancels out. And then 30, negative 30 minus negative 35, so that becomes plus. So when we subtract these terms, we get 5, and there's no other place for us to go, so that means this is the remainder. So the way that we would actually write this would be x plus 7 plus the remainder over our divisor, x minus 5. So this is the solution. Whereas up here, our answer was just x plus 5. This one has a remainder, so that 5 could not go into the x minus 5 anymore. That's why we wrote it over that. So that means that x minus 5 is not a factor of x squared plus 2x minus 30. Okay, so let's go ahead and do some more. So does McDonald's sell burgers? Repeat, just to remind ourselves of the steps. So the first things first, we're going to go ahead and set up our equation, x minus 3. And then underneath we have to make sure this is in standard form. So 6x cubed, cubic term, quadratic, linear, constant. So we're not missing any zero placeholders. We can go ahead and write that in. So 6x cubed minus 19x squared plus x plus 6. And then let's go ahead and do our work off to the side here. So D stands for divide the first terms. So 6x cubed divided by x gives me 6x squared. This is quadratic, so it goes above the quadratic terms. M stands for multiply, so I multiply this times each of these and then line them up. 6x squared times x gives me 6x cubed. 6x squared times negative 3 is minus 18x squared. And then we are going to subtract. So again, if you want to write the subtraction on the outside or just change the signs, that's fine. So 6x cubed minus 6x cubed cancels out. And then negative 19x squared minus negative 18 becomes plus. So that becomes x squared, negative x squared, sorry. And then bring down for b, bring down your other terms. So plus x plus 6. R stands for repeat. So divide the first terms. Negative x squared divided by x is negative x. And then M stands for multiply. So now I'm multiplying this negative x times both of these terms. So negative x times x gives me negative x squared. Negative x times negative 3 would be positive 3x. And then we are going to subtract. So this becomes a plus because you have minus minus. And this becomes a minus because it was positive. So negative x squared plus x squared cancels out. X minus 3x becomes minus 2x, and then B stands for bring down the 6. R stands for repeat. So divide the first terms. Negative 2x divided by x gives us negative 2. It's a constant, so that goes above the constant terms, minus 2. And then, of course, M stands for multiply, so we multiply negative 2 times x, which is negative 2x, and negative 2 times negative 3, which is positive 6. S stands for subtract, so negative 2x minus 2x, that becomes a plus, those cancel out. And this becomes 6 minus 6, which is 0. There's no other place for us to go, so this is the remainder. And that means that my solution is 6x squared minus x minus 2. So that is the answer, which means that x minus 3 is a factor of the dividend because we didn't get a remainder. So go ahead and see if you can do number 9 on your own. When you're done, pause the video to check your work. All right, so let's go ahead and set this up. We have the x plus 3, and the dividend is x cubed minus x squared plus 4x minus 10. And we're going to do our work off to the side here. So here, I wasn't missing any zero placeholders. This is a degree 3, 2, 1, 0. So D stands for divide, our first term. So x cubed divided by x gives me x squared. It's quadratic, so that goes above the quadratics terms. Then you multiply. So that gives me x squared times x is x cubed. X squared times 3 is 3x squared. S stands for subtract. So x cubed minus x cubed cancels out. And this becomes negative x squared minus 3x squared, which is negative 4x squared. B stands for bring down the terms. So plus 4x minus 10. R stands for repeat. So divide the first terms. Negative 4x squared is now that first term. Divide that by x. That gives me negative 4x, which is now linear, so it goes above the linear terms. Then M stands for multiply. Negative 4x times x is negative 4x squared. Negative 4x times 3 is minus 12x. Then subtract, so this becomes a plus when you subtract, and negative again is a plus. So negative 4x squared plus 4x squared cancels out, which we did on purpose. 4x plus 12x gives me 16x, and then bring down the 10. And then repeat. So 16x divided by x gives me 16. It's constant and it's positive, so plus 16. M stands for multiply. So 16 times x is 16x. 16 times the 3 gives me 48. And then we're going to subtract the terms, so both these become minus. So this cancels out, and then negative 10 minus 48 gives me negative 58, which is the remainder because there's no other places for us to go. And so this becomes x squared minus 4x plus 16 minus 58 over x plus 3. So that is the answer to this polynomial long division problem. All right. Looking at question number 10, so this problem is slightly different because notice that this is in standard form, but we are missing zero placeholders. This is degree 4, degree 2, and degree 0, so we're missing 3 and 1. So we need plus 0x cubed and plus 0x when we write this out. So here we have x plus 2, and then x to the 4th plus 0x cubed minus 2x squared plus 0x minus 20. So we need those 0 placeholders. So D, M, S, B, R to remind me of the steps. So do my work off to the side. D stands for divide, my first term. So x to the 4th divided by x. And that gives me x cubed. To line this up with the cubic terms, that's why we need that 0 placeholder there, so we have a spot to put this. So x cubed, then we're doing m, is being multiplied. So this is x to the 4th, and then that would be 2x cubed. S stands for subtract. Those cancel out. Negative 2x cubed, and B stands for bring down, so minus 2x squared plus 0x minus 20. Go ahead and pause the video and finish the rest on your own. When you're done, you can unpause to check your work. So then, again, we're going to repeat. So negative 2x cubed over x gives me negative 2x squared. It's quadratic, so it goes above the quadratic terms. M stands for multiply, so I'm going to go ahead and multiply this by both of these and then line them up. So negative 2x squared times x is negative 2x cubed. Negative 2x squared times 2 is minus 4x squared. And then we subtract the terms, so minus minus becomes plus for both of these. This cancels out. 2x squared plus 4x squared gives me 2x squared. And then bring down the other terms. And then repeat. So 2x squared over x is 2x. It's linear and it's positive, so we're adding it. M stands for multiply. So that gives me 2x squared when I multiply 2x times x. And 2x times 2 is plus 4x. And then subtract. So this becomes minus. These cancel out, so negative 4x, and then bring down minus 20, and then repeat. So negative 4x divided by x is negative 4. It's a constant term, so that goes here. And then multiply. So that gives me minus 4x. And then negative 4 times 2 is negative 8. And then we subtract, so that becomes plus, and that becomes plus. This cancels out. Negative 20 plus 8 is negative 12. And there's no other spots for us to go, so this is the remainder. And so then the answer to this long division problem is x cubed minus 2x squared plus 2x minus 4 minus 12 over x plus 2. So of course that means that x plus 2 is not a factor of the equation because we did not get 0. Go ahead and pause the video and see if you can do number 11 on your own. When you're done, you can unpause it to check your work. So now notice that if all the other ones we were dividing by a binomial, this one we're dividing by a trinomial. So this goes on the outside, 3x squared minus 3x plus 2. If I was missing any 0 placeholders here, I would also write them in so I don't forget to multiply. Here I have 6x to the fourth. I'm missing my cubic term, so plus 0x cubed. This is degree 2, degree 1, degree 0. So we're just missing that 0x cubed. So 6x to the fourth plus 0x cubed plus 7x squared plus 4x minus 17. And again, if you are missing that 0 placeholder, please make sure to always write it in because you don't want to forget to put terms where they go. So the first thing we want to do is divide. So 6x to the fourth over 3x squared. 6 divided by 3 is 2, and x to the fourth over x squared is x squared. It's quadratic, so that goes above the quadratic terms. 2x squared. M stands for multiply. So now I'm multiplying not just by the two terms, but by all three of these terms. So 2 times 3 is 6, and x squared times x squared is x to the fourth, so 6x to the fourth. 2x squared times negative 3x, so that gives us negative 6x cubed. That's why we want this 0 placeholder. Then the next one we have is 2x squared times 2, which gives us 4x squared. And then S stands for subtract. So I'm going to change the signs of each of these to encircle to make sure I remember I already changed them. So this cancels out. This is 6x cubed. 7x squared minus 4x squared gives me 3x squared. Bring down the other terms and repeat. So 6x cubed divided by 3x squared gives me 2x. So that's positive 2x above the linear terms. M stands for multiply. So 2x times 3x squared gives me 6x cubed. 2x times negative 3x gives me negative 6x squared. And 2x times 2 gives me 4x. S stands for subtract, so this becomes minus, plus, minus. This cancels out. 3x squared plus 6x squared is 9x squared. 4x minus 4x gives me 0x. And then bring down the minus 17. and repeat. 9x squared divided by 3x squared. 9 divided by 3 is just 3, and x squared over x squared is just going to give us times 1, so 3. So that's positive. And then now we multiply. 3 times 3x squared gives us 9x squared. 3 times negative 3x is minus 9x. 3 times 2 is 6, so that goes here. S stands subtract. So changing those signs, this cancels out. 0x plus 9x is just 9x. Negative 17 um, minus the 6 is negative 23. And then notice that there's no other spots for us to go. And even if we try to divide the first terms again, I would have 9x over 3x squared, which if I did this right here, I would get, notice 9 divided by 3 is 3, and then this is x to the first power, so 1 minus 2 is x to the negative 1, so 3 over x. So we don't want to have those in our denominator unless it's a remainder, so that tells me that this is the remainder. So the answer to this division problem is 2x squared plus 2x plus 3, and then plus 9x minus 23 over 3x squared minus 3x plus 2. So it can get a little bit complicated, which is why it's really important, again, to make sure you put those zero placeholders in. It's really important that you understand your properties of exponents because, as you can see, that's why we went over them in that first lesson because we're using them a lot. And again, this is going to apply to what we're doing because we're going to figure out if something is a factor of a polynomial, which then helps us find the x-intercepts of our graph so that we can graph them. So that's it for this lesson.